Hello, welcome back to the channel. Today I'm going to resurrect this old subwoofer system of mine. I made this subsystem more than 20 years ago with some Dayton Audio 12-inch subwoofers that I got. I bought 4 of them at the time, and I built 2 of these systems, 2 boxes with 2 12-inch woofers in them each, and I'd driven them by 2 PV850C power amplifiers. Very, very powerful system. It served me very well in my home theater downstairs. However, when my boys grew up, they kind of kicked me out of that home theater and claimed it as their own. So this subsystem unused for years. So that got me thinking, my main living room that I spend most of my time in now to watch televisions and to watch the news has just a consumer grade subsystem, just a off-the-shelf powered sub box that I got at a big box store some years ago, and it's good and it's plenty powerful and it serves me well in that room. But why not use this subsystem, which is very overpowered in comparison? So I wanted to get this thing back in action, and today is the day I'm going to do that. And part of what inspired me to do this here and now is I found this at Canadian Audio Mart, or CanadaAudioMart.com or CanadaAudioMart.ca. It's an audio-controlled phase-coupled activator, long discontinued. It's a specialty piece that restores lost bass in recordings and makes your system very, very powerful in the end. The trouble with the phase-coupled activator is it produces so much low-end bass, or it has the ability to anyway, that it will destroy most consumer-grade subsystems, which is why it's ideal I have a subsystem that's this overpowered. I'm going to do an entire separate video on the phase coupled activator and the many glorious things that this thing can do for a subsystem. But for now, let's look closer at exactly what am I doing to resurrect this system. I needed a new amplifier for this. I didn't want to use my PV amplifiers that I had using in the home theater room downstairs that I was using for these subs for years. Great, very, very powerful amplifiers, but it's a separate standalone amplifier with a built-in fan to keep it cool, and that fan was very noisy. It didn't matter in the home theater room downstairs because all my AV gear was kept in an AV closet detached from the room, so you never heard those fans. But in my TV room up here, I would hear those fans. So I wanted to go Class D. I went to partsexpress.com and I shopped their Class D digital subwoofer plate amplifiers, and they have a lot of great choices. And one of the reasons I wanted to go Class D was for the power efficiency, that you can get a lot of power from a small space and draw less energy from the wall in doing so and generate less heat. So there's a lot of great advantages to Class D, and I've gone Class D elsewhere in my house for main speakers, but never for a sub amplifier, and today's the day I'm doing that. But I landed on this glorious piece. It is the SPA500DSP, and it's the DSP part that makes this so damn special. Right here you've got a control on your amplifier that allows you to control many things through the screen right here on this amplifier, and through this, the digital signal processing allows you to adjust the crossover frequency, the phase of the subsystem, which allows you to blend in the subsystem to your main speakers, at least give them time aligned. And this DSP can do a lot more things as well. You can control the DSP through this control knob here, and or you just plug it into your PC through this USB port and use the free Dayton Audio DSP software that's downloadable for your PC. It gives you a lot of extra control over your subsystem. I really, really like it. But why this amplifier? Dayton Audio has a few other great Class D amplifiers to choose from, and I'm going to tell you exactly why. Is when on their website I stumbled across this glorious piece, and what it is it's a mounting bracket for the amplifier. It simply mounts like this, and this allows you to mount this amplifier onto a sub box as opposed to in a sub box. I can mount it on a box just like this, as opposed to a typical plate amplifier. The big reason, really, if you're going to have a plate amplifier, you need to cut a hole in your sub box this size, and you mount it using the mounting screws on the amplifier. You're going to cut a hole in your box, put this in the hole, screw it in place, and the point there is, well, you have a giant hole in your sub box, which I've never really liked that idea of putting a hole in this beautiful sub box. You'll see in the pictures that I put up on the screen here is that one of the big design advantages of this particular sub box is the internal bracing. I model the internal bracing that's in this subsystem after the Bowers and Wilkins 801 studio monitors. 30 years ago, I used to work in an AV store selling AV gear, and of course, our biggest pride and joy inside that store was the B&W 801s. And one of the biggest breakthroughs in technology as to why did that speaker sound so good, there was a number of reasons why that speaker sounded so good then and more so today, is that matrix bracing inside the cabinet. So with that experience, having experienced those speakers, when I built this subsystem, I wanted to recreate some sort of internal bracing like that 801 speaker inside this, and these photos show you how complicated this internal bracing is, and it really is an indicator how structural this box really is. And this box is incredible, which is really a big reason why I didn't want to cut into this box to mount a plate amplifier. This box is glorious, and I figured cutting a hole is something I didn't want to do. So this mounting bracket allows me to mount this amplifier onto the box. In fact, I'm going to mount the amplifier right here, right in front of the speaker terminals. So that allows me to hide the speaker terminals. And I'm going to get a little creative because unfortunately there's not quite enough real estate for this amplifier to go here. As you see, it's kind of going over top of the woofer. So I'm going to get a little creative, and I'll show you exactly how I'm going to do that. I'm going to mount this amplifier to the box, not inside the box, right here, with a little bit of it being over top of this woofer, and it won't be a problem. All thanks to this wicked mounting bracket. Let's get to it. Okay, so I've mounted this amplifier onto the sub box, and I paid particular attention to make sure that this surface here was a little bit off of this surface, so because I wasn't sure exactly which way was going to be up on this subsystem. Is this going to be the top of the sub? Is this going to be the top of the sub, or the bottom? Is this the bottom? Is this going to sit on the floor, or is this going to sit on the floor? I wasn't exactly sure. I'm still not sure. So presuming this ends up being the bottom of the subwoofer, I wanted to make sure that this didn't touch the floor when this touches the floor. So that's why I left this gap here. I pushed this amplifier this way to keep that from hitting the floor. And I did the same here as well. If I end up orientating this to be the bottom of the subsystem and this sits on the floor, I didn't want this sitting on the floor, so I left a bit of a gap here. But I mounted the plate amplifier enclosure housing to the box, as you see, using these standoffs. Now these standoffs is just rubber water hose. This is just rubber water line that I picked up at the hardware store, and I spray painted them black so they would fit. And that gave me these standoffs that allow this amplifier to stand off while still being mounted. And as you see, it allows it to sit over top of this driver. So when this driver moves in and out, you'll see it allows for motion, and it in no way is going to hit the bottom of this amplifier. Unfortunately, as we see the orientation, there wasn't quite enough real estate on the face of this woofer, the face of this sub box, to mount this without that. So by putting these standoffs in there like this, I was able to get this to sit up even higher and not impede with the action of the sub. I'm really quite impressed. And of course, being rubber mounted now, because this amplifier housing is now mounted to the box with rubber, it's going to protect the amplifier a little bit from the vibrations that this subsystem is going to produce. Now, let's get, let me get my there we go. Let's get the amplifier mounted. Now, I do have a small problem. Here's the problem. This amplifier is very powerful, 500 watts into 4 ohms. One channel is a subwoofer amplifier, and ultimately has one channel at 500 watts, but into 4 ohms. So ideally, you want to give this amplifier a 4 ohm load. I bought these subwoofers so long ago, maybe as much as 20 years ago, I have no idea what the specs are. So this morning, I pulled the driver out of the box, and I was hoping to get a model code off the back, you know, a sticker, a label, something on the back of this driver to see what the model code was, so I can go to partsexpress.com and download the data sheet for this thing and get the feel small parameters to see, is this a 4 ohm driver, or is this an 8 ohm driver? Because if these are 8 ohm drivers, I'm going to want to wire these in parallel. 2 8 ohm subwoofers wired in parallel gives you one common 4 ohm load, which is exactly what this amplifier wants. And that'll give me 500 watts of power from this amplifier into these 2 drivers. However, if these are 4 ohm drivers, and they may very well be, if I wire them parallel, that'll give this amplifier a common 2 ohm load, which is great if this amplifier is 2 ohm stable. And I don't know at this point if it is 2 ohm stable. I will research it, and if this amplifier is 2 ohm stable, I will wire this in parallel and get even more power out of this amplifier. But if it's not 2 ohm stable, I'm going to blow up my brand new beautiful amplifier. So to be safe, I'm going to have to wire this sub in series, presuming they're 4 ohm loads, 4 ohm drivers. 2 4 ohm drivers wired in series will give me one common 8 ohm load, which will give me half the power. But that's the safe bet. An 8 ohm load, I'll get 250 watts. It's still a ton of power for a subsystem, just not all the subsystem that I paid for. I paid for 500 watts. I want 500 watts, so I should be wiring them in parallel, but that could be dangerous if these are 4 ohms. Here's the real oddball thing, is if these are 8 ohm drivers, wiring them in the series gives me a common 16 ohm load, which potentially gives me 125 watts out of this amplifier. Again, not even remotely what I paid for. So I'm going to do a little bit more research, and ideally I want to wire these in parallel. But to be safe, for here and now, to get this thing started, to make some noise, I'm going to wire them in series. Let me show you how I do that. Okay, I threw my multimeter on here onto each pair of terminals, and I did get what appears to be a common 4 ohm, not a common 4 ohm, but a 4 ohm load per driver. Now, I'd rather not trust a multimeter. I'd rather trust the data spec sheet, because it could be different, because a multimeter doesn't consider frequency range as to operational frequency range. It just looks at the inductance of the coil itself. But my multimeter does say that these are 4 ohm drivers, so I will not wire these in parallel. I'm going to wire these in series, or I have, as you can see, wire them in series. So I've got the positive of the amplifier. Here's the amplifier, all wired up, as you can see. I've got the positive of the amplifier going into the positive of one of the drivers, and then I have a jumper lead coming out of the negative of the other driver, jumping over to the positive of the other driver, and then the negative terminal of the amp is coming out of the negative of that. So as you can see, it is wired in series, and that'll give me a common 8 ohm load. Less than ideal, but as I said earlier, if If, after doing some research, I discover that this amplifier is capable of handling a 2 ohm load, well, then I'm going to wire this in parallel and get even more than 500 watts out of this thing, because of course, wired in series, I'm getting approximately 250 watts, which is gobs of power. It's just not all of the power that this amplifier is capable of. So for now, we're going to wire it in series, and we'll get this thing buttoned up, get it plugged in, and see how things are going to go. So let's get this plate mounted. There you have it. It is mounted and wired. And ready to go. I'm going to plug this bad boy into my living room, get it making some noise, and let's see what it can do. It has plenty of power, far more power than I need here. So initial reactions, I love it. With that said, I've already picked up one concern, and that is, can you hear that? There's some hum. There's some hum coming from the drivers when there's no music signal going to it. It's humming right now. I'm not sure I like that hum. I would rather have no hum. I'd rather it be silent. Now I'm hoping, cross my fingers, I'm hoping that will be silent, as you know, from my seating position. Of course, I'm going to spin this woofer system around so the drivers face into the wall, because my wife won't like the look of that, plus it'll protect the drivers having them face the wall, and hopefully that'll kill that sound. You know, it is a high frequency noise, and the wall boundary should eat that up just fine, hopefully. If not, of course, I got the gain a little bit high on this for the sake of testing. Surely I'll be turning that down, and I think by turning down the gain, that'll also take away some of that noise. Line noise, I'd rather not have the noise, but big power. And again, the big advantage of Class D is the efficiency, as in we're drawing very little amperage from the wall socket. This is an old house, and in fact, in the province of British Columbia where I live, houses were built in the 70s for only 4 years with aluminum wiring in the walls. Aluminum wiring was very, very good at conducting electricity. The problem with aluminum wiring is it would expand and contract at the contact points, let's say at the socket. When you put it under load, it would expand, and when you take it off load, it would contract, and expanding and contracting, expanding and contracting over the years, it would cause a contact failure, which would generally lead to an arc inside the socket, and that arc has been known to burn down houses. So our house has been converted. We didn't convert the aluminum wire to copper, but we converted each electrical box to copper ends to prevent that expansion and contraction inside the box. It's done, done by an electrician. It's done safely, so it reduces. My point is, because of that experience of having lived in a home with aluminum wiring, knowing that that can burn down your house if you don't care for your sockets and have them converted over like we did, my concern is power consumption. I want to keep my power load down, for a number of reasons. It's good for the environment to not use more electricity than you have to, but it's also good. I certainly don't want to load up my sockets any more than I have to. So going Class D was a brilliant solution by going, Class D amplifiers compared to a traditional Class AB amplifier. Class AB amplifier can be as power inefficient as only 20 to 30 power is used to make sound, whereas the 70% of the power consumed is offloaded by heat, which is terrible. It's terribly efficient for a Class AB amplifier, whereas a Class D amplifier is often higher than even 90% efficient. I don't know the efficiency of this amplifier, but it's going to be close to 90%, maybe greater than 90%, which means it only loses 8 to 10 or to 12% of its energy consumption to heat. So it's drawing far, far less power from the wall socket, which I love. It's good for the house, it's good for the environment, and hey, it runs the amplifier cooler, which should mean a longer lasting amplifier. And with performance like this, I have no reason for concern. So stick with me. If you like this kind of content, subscribe to the channel and give it a thumbs up. Give this video a thumbs up. That'll get the video out to more people who are looking for content like this. Plus, if you want to see more about the phase coupled activator, because all of this action was without that phase coupled activator installed. I am going to install that phase coupled activator and do a video just on that. So subscribe to the channel so you can get some updates when I do the review of that phase coupled activator and see what kind of destruction we can do with this subsystem.